have one final example for today. It's one that I think I did something similar to on Friday, but it's a really important type of question, and it's shown up on STAR at least once, but I think 2 or 3 times I've seen it there. Since I don't want the STAR to be the first time that you see a question like this, we're going to go through it again today. The perimeter of square 3 is 36 units. That means all of these sides together, all 4 sides, add together to make 36 units. The perimeter of square 2, all 4 sides together, and it is a square, is 48 units. It wants the area of square 1. Area is not the length around, but it's all of the space inside. Find the area. Let's fill in this problem-solving board. We need the area of square 1. We know P3 is 36. We know P2 is 48. And we know that the perimeter of a square is equal to 4 times the side. So to solve this, we're going to need to use the Pythagorean theorem because we need this side length. We need the hypotenuse of this triangle. Once we get the hypotenuse, we're going to square it, and that'll be the area. The first thing we're going to have to do before we can do that is we need to turn these perimeters into a side. We need to find the side first. So let's do square 2. 48 is equal to the perimeter of the square. The perimeter of the square uses the formula 4 times the side. That means 48 is equal to 4 times the side. So let's just divide both sides by 4 to get that the side is going to be equal to 12. And that's for square 2. This one's going to be 12 units. Now let's find the side of square 3. Square 3's perimeter is 36 units, and the formula for perimeter is 4 times the side. So if we just divide by 4, then we'll get that 9 is equal to the side. So let's just label that 9 units. Now we'll use the Pythagorean theorem, so that way we can find the hypotenuse. I need this stuff to be gone because I need some more space. Let's do 9 squared plus 12 squared equals c squared. 9 squared is 81, 12 squared is 144. That'll be equal to c squared. It's going to make a 5, a 2, and a 2 equal to c squared. The good news is when we square root this, 225 is a number that you should have memorized, or we've seen it before. It's going to be the number 15. 15 is c, so the side of square 1 is 15. But the question didn't want the side of square 1, it wanted the area of square 1. Side of square 1 is equal to 15. So the area of square 1 will be equal to 15 squared, which means that the area is equal to 225 units squared. If you were paying attention to these numbers and not just listening, if you were following along and thinking about things, then you would have seen that this area was found back here. The reason that is because another way to see the Pythagorean theorem in a different perspective is whenever you square this 12, whenever you do 12 squared, that's going to give you an area. And then whenever you do 9 squared for square 3, that's also going to give you an area. And a way to see the Pythagorean theorem from a different perspective is we are adding together the areas of two smaller squares, and those two areas, when we add them, is going to be equal to square 1. So the Pythagorean theorem, when we're squaring these numbers, we're really adding together areas. That's an area and that's an area. And when we add together areas, your answer is still going to be an area. You don't have to remember that. You could just solve for the side length like we did, and then square it again. But for people who are interested, the Pythagorean theorem is all about areas of squares, which happens to also be able to form a right triangle.